Okay, welcome again. My name's Hofer from Schindler, my colleague Püntener. We've worked together many years and had the opportunity as well to work on new technologies. Again, technology redefining the future of elevator installation methods for high-rise buildings. Obviously, construction sites aren't sexy. I mean, we differentiate in the environment. It's a harsh environment, safe with high safety standards. Repetitive time, consuming manual work, high quality requirements, again guide rail alignment, shortage of the qualified and motivated labour force. That's always a problem, trying to find the people and to keep them motivated. And again, challenging logistic environment, especially supply chains during COVID. And demanding time schedules. I think that's again one of our sort of key contributors. If we look again, we try to standardise the process and then the method and tools, and that comes again in this digitalisation world that we have. We have the tools, we have the applications, and then the technology and innovation. Here as well, we have installation excellence. I mean, it's nothing new to the industry, a false car, a suspended platform. Our idea was just to make this very mobile, that we can come up to the job site straight away and start work. So as soon as the elevator hoistway is actually handed over, we're independent on site and ready to go. So with this, again, depending what kind of the building stage is it in, you could, in this where we have a crash deck, the actual building is still being constructed. And we come in with this kit, which we called SLIM, scaffoldless installation method. And the hoistway platform is actually 4.5 metres so that we can drive over the guide rails to keep less pressure on the guide rails as we're installing. With this, the brick installation we have here, this is giving us basically 8 plumb lines to get the accuracy of those guide rails and counterweight rails. With a self-contained hoistway protection, again the suspended platform, a primary, secondary rope. This was developed and certified in 1808. So that keeps us for people transport, person transport certified. The platform as well, where we have a lean to beam. These are all programmed on the actual drawings of the layout as well. We know the force of the back wall. Can we use this lean to beam to lean on the back wall, put in this hoistway platform, the brick. So the time spent here is basically 6 hours. We can be up and running to start plumbing that hoistway. And then half a day for this installation, where again, it's safe, it's efficient, sustainable and independent. I think independent being the key word. We don't have to rely on people, on the builders. As well, another option which we have is a climb lift, been around for centuries I think. Very interesting to be able to have an up and running lift in the building phase. Here as well, you basically have your lifting platform, crash deck, which is optional, machine on the platform, which is then movable, and then back to this false car, which will be doing the installation as we're maintaining. As the lift is actually running then underneath, and as we can see, again, it's limitations. There are no limitations in travel height. Up to 500 metres, 5 metres a second, and a 5,000 kilo car. And for all those people that have been on a building site and relied on the alimak or any hoist, it is really a total game changer to be able to have an operation lift during that building phase. Just some examples of the efficiencies that we gain. If you see the external hoist or an alimak on the side of a building, can only do 20,000 kilograms, and with a climb lift we can actually do 48,000. And then again to the people flow, 260 people with a conventional hoist, and with an elevator running then 600 people, and obviously the speed from 1 metre to 3 metres a second. So yeah, nothing new in the industry, but obviously the benefits, again, strengthened work safety, increased capacity, reduced waiting time, and improved site logistics management, all-weather operation, and probably one of the keys is the earlier facade closing, which we really do appreciate. Then we can use all that with our BIM, which building integration model, where we have the full digitalisation, elevators, escalators within that building, coming to the digital side of it. Again, the benefits where we have investors, for the investor, the builder, consultant, lead designer, facility manager. It reduces the number of errors during the installation and operation. Again, faster design approval once you can have the plans, the turnaround of the plans. Consultant, lead designer, coordination is obviously improved, and the communication and earlier error identification. I think that's probably one of the most important things that we have. Facility managers, they get to monitor the equipment status and the schedules for the maintenance. The benefits are there for sure. I think the industry is turning in that direction. Even when we have then a digital twin set up, that you actually have a model of that whole unit, and you can take that through the life scale of the building with its, the maintenance as well. We know when parts have been exchanged. The digital twin is an amazing product. Back to some global benefits again. Again, I think the site coordination would probably be the key one. We know exactly the state of the building, what's going on, is the hoistway complete, what needs to be the next steps, you know, allocation of where the fitters are on the job site for safety, who's working in which hoistways. Again, we have, instead of running that manually, which was quite challenging, we can on a daily basis look at that and see where we are in the construction phase, and a higher customer satisfaction rate. So BIM, you know, we look at the three independent, again, SLIM, which is the scaffoldless installation method, climb lift. We've actually had buildings where we have all that integrated, and then with the BIM, and then the latest, the new addition, which we have, is the Schindler Rise. Again, the robotics coming back to safety, where we can take people out of the hoistway, and we have a robot doing the dirty and dusty work of installing an elevator. And with that, I would like to hand over to yours. All yours.
Perfect. Thank you very much, Phil. Yes, I will have the pleasure to talk about this Schindler Rise product to you. Going forward, we were really thinking, you know, how can we actually build on this roadmap Phil has just shown, and how can we become more efficient in the installation, but also how can we address people safety and health. And we were actually, you know, putting a lot of brain into this and say, okay, how can technology help us here, you know? And the solution finally was found in robotics. I mean, you know, the days where robots were only working, you know, in assembly lines, in manufacturing facilities are over. Robots are all over the place now. They got mobile, and we were thinking, hey, why not try, you know, to also use a robot? And I'm actually very proud to present you here, colleagues, the Schindler Rise. This is Schindler robotic installation system for elevators, world first robot who can do elevator installation work totally autonomous. So what is this robot about, and what actually can it do? So the robot is basically brought into the shaft, and once it's commissioned, it is fully autonomously going vertically up and down to find the position where it would execute then its work. Starting with a first wall scan, the robot is equipped with a wall scanning unit, where the robot first check, are the dimensions which are programmed in the configuration file, are they correct? So we're checking actually the dimension in the shafts, are there any obstacles, before we would do then any other work in the shaft. Secondly, it would then change the tool and would go to a wall scanner, which allows the robot then to scan the wall and to see actually where the rebars are sitting in the walls. And with this, the software can then exactly distinguish where the robot would drill the hole at the end of the day. So we have slot holes in our wall brackets, and that tolerance is known to the robot, and then the robot would in the software exactly distinguish where it would start to drill to avoid actually the hit with the rebar. And then afterwards it would change the tool again and would then take the drilling machine and would then actually do the drilling work into the shaft wall. So We can drill actually the holes for counterweight rails, for the main guide rails. We can do divider beams for multiple shafts, and we can also do the holes for the landing doors. And then the last step the robot is actually doing, it would change the tool again and would fetch an anchor bolt, which the robot carries on the arsenal of about 100 meter travel height. So fetch the anchor bolts and would set it then into the drilled hole. Once the whole ring has been drilled and anchor bolted, the robot would then move autonomously to the next floor, where it would then start to conduct the next ring of drilling and anchor bolting. Good. Where are the benefits here, mainly for the customer or for the main builder when we provide such a solution? I think we start here clearly with safety and health. Drilling holes into an elevator shaft, this is rather a cumbersome work. It is noisy, it is dusty, it is exposed to height, it is not very ergonomical, and our fitter, our workforce, they don't like to do this actually. So it's basically taking that part of the elevator installation away, and it would be conducted by the robot, as I say, fully autonomous. Then you can imagine a robot can work 24 hours, you know, there is no bio break needed, there is no smoking break, we really can go through directly. And as I said, the robot is equipped with anchor bolts for a 100 meter shaft, so we can basically commission it and let it run. And if the job site allows us to work 24/7, it depends a little bit, you know, if the noise exposure, if we can work through, but the robot actually is able to drill straight through. So I have to speed up a little bit. Quality, we have a digital image on board, which we have seen before from BIM, so the robot knows exactly where to drill, so the drilling accuracy is very, very high. Marketing, we have a huge impact because the contractor for us is the main builder and often also seeks for technology. He can actually then also promote towards the investor. So this is a great marketing instrument we have here and very much appreciated by our key accounts. And last but not least, it's also about people because, as I said, people do not want to drill holes today. We have difficulties to find people that do the elevator installation for us. So to be a Schindler Rise operator is a much better job than, you know, drilling hundreds of holes into a shaft wall. Good, before I'm going to close here, this is just a little outlook or a footprint where we have deployed this technology already. So it is not just existing on a paper, it is real. And these are the buildings we already have utilized this technology. And having said this, I would like to invite you just quickly to come with me to the Warsaw Tower, which is a 310 meter tower located in capital city of Poland. It's the tallest building in the European community. And you would see here how this technology comes, then in combination also with climb lift, as we have heard before, and slim.
Gentlemen, thank you very much.